Hello, Per-Ola Malmqvist from Sweden here, fire protection engineer and former battalion chief. I've been making some tests detecting battery fires to see if it would be possible to get some early warning, and in that case, how early warning that could be. The thing I've been thinking about was if I could add that to my smart home like I have done with my washer and dryer. Here I have a regular smoke detector above my washer and dryer and connected it to smart plugs that will, through a program, if the smoke alarm goes off, it will shut off the smart plugs that supports the power to the washer and dryer, and also give a fire alarm. And this is the way we normally talk about thermal runaways. Like first nothing happens, and then nothing happens, and then suddenly we have a thermal runaway. But if we look at it in more detail, what really happens is that we have some off-gassing before the thermal runaway. And if we zoom in here, we can see that we have 10 minutes in this case where we have different gases, one of them being carbon monoxide, another one being hydrogen that is not shown in this diagram though, but I know that those are gases that are worked on to detect the early stages of a thermal runaway. Here is another diagram of another test, again around 10 minutes of early warning. However, it doesn't work all the time. This is another test where there were no early warning at all. So even if it's possible to detect, it might not work all the time. And here is what I'm talking about. If you see there was a spray of a liquid and then we have this smoke. What happened was that the PRD, the pressure relief device, opened and while releasing its pressure, the white you see here that looks like smoke is aerosols from the electrolyte, and the gases we saw in the diagrams are released. And if you look at this here, like a replay, you can see that there were small drops of the electrolyte hitting the window here, and then that is evaporating. So we will look in this video at detecting the carbon monoxide gas, the smoke like with a regular smoke detector, and also the electrolyte, the volatile organic compound that was released that you saw the drop on the window. I will start with the results, so there will be no cliffhanger here, but at time 0, that is when the PRD opens and we get the off-gassing. At some point between 13 to 17 minutes, and in some cases not at all, we got a thermal runaway. And the domestic CO detector did never work at all. It was always too late when that detected enough CO to give away an alarm. The optical smoke detector worked once, and in all the other cases it did not sound the alarm until after the thermal runaway. I had a programmable CO detector at 10 ppm, and that worked after around 4 minutes, and that is about 10 minutes ahead of the thermal runaway. Then I tried a ProTech cloud chamber sniffer that is used to detect smoke from fires, and it really it detected it after like 30 seconds or so. And then the lithium ion tamer that detects the electrolyte vapors, the VOC, detected it after 7 seconds. So there is a good chance of detecting a battery fire ahead of the thermal runaway. So my thoughts were before the test that a carbon monoxide detector should work to detect a lithium-ion battery fire. And if that would work, then it would be possible to build a battery box that would give an early warning of a thermal runaway it would shut down charging, and it would give me a way to transport the e-bike battery outside safely based on where I'm living. I say that because every different location for charging and storing would need a separate solution that you would need to look at. But for me, living in a house, having the garden right outside, I don't have to take the battery box through any emergency stairways or anything else that would be a danger to other people. This would work. And then I had this thought about normal carbon monoxide alarms. They are made to detect errors in domestic combustion installations. So they have different levels when they give away an alarm. For example, if you have only 30 ppm, that would take 30 days until they give away an alarm. If you have 70 ppm, it is between 1 and 4 hours between the alarm starts. 150 ppm is a little shorter time, and 400 ppm is between 4 and 15 minutes. And my hope with the testing of the normal CO alarms was that there was going to be so high levels of carbon monoxide that it would bypass all those levels and start the alarm immediately. On day one, I started with a reference test. I had a soldering iron, that is the one I'm using to heat the battery cells, in a box, and I have the carbon monoxide alarm inside the box. And in this reference test, I just tried so I didn't get any carbon monoxide from the soldering iron alone. And it didn't. So with that, I started the first test. Now you can see the soldering iron. You can see there is a temperature meter. One of the temperature is on the soldering iron, and the other one is on the back side of the cell. And they were more for me, so I know that I had some heating going on. And when I see the first sign of smoke, I will show that here on the scale. And then I start fast forward again, and we'll see if we get any carbon monoxide detection at all during the test. You can see that we get more and more of the off-gassing of the aerosols within the box, but still no sound from the carbon monoxide alarm. And here we will soon have the thermal runaway combined with an explosion of the gases that was collected within the box. And no alarm from the carbon monoxide detector this time. Second test, we added an optical smoke detector. So we have one smoke detector and we have one carbon monoxide alarm in here. Again, first smoke is showing. It's hard to see it here, but you can see that there will be a little more hazy inside the box. And here we have the smoke detector go off. And this was the only time during the test that the smoke detector went off ahead of the thermal runaway. I can't explain why, but maybe it's sometimes it works and sometimes it doesn't. But it was very little smoke or off-gassing within the box when the smoke alarm went off. And now we have a little more and we have the explosion again. Nothing from the CO detector. Test 3, same thing here. Now we had both the carbon monoxide detectors in the box, just to make sure that one of them wasn't faulty. Now it was a little bit harder to see when we had the first off-gassing, but the PRD opened there and we get the off-gassing coming out into the box. "10 minutes, 12 minutes, nothing happening. And around 14 minutes we again have a thermal runaway with an explosion in the box. So my thoughts after day one was that domestic CO alarms does not work. And a regular smoke detector was faster than the domestic CO detector. That was not something that I had expected. And it was only in one test, but on day one I only tested it once. So that was 100% success rate from day one. I need to find a carbon monoxide detector where I can program the levels, so I could set a low level of carbon monoxide and no pre-warning time, so it's set off immediately. And I would like to measure the carbon monoxide during the test. And I was thinking, because I've tried a super sensitive aspirating fire detection system earlier with cloud chamber technology that is really sensitive to smoke. So I wondered if that would be a good thing for battery fires as well. And I also would like a better box to see what happens inside the battery box. So for day two, I found a programmable carbon monoxide detector from Fibaro that is possible to connect to the smart home. I borrowed a carbon monoxide monitor, an aspirating one that sucked out the gases from the box, and I could read out the carbon monoxide levels inside. I also borrowed a ProTech aspirating fire sniffer. I built myself a new box, and if you look at this box you can see there are 5 holes in the bottom of it, and in the middle one there is a small shiny thing sticking up. That is the top of the battery cell with a pressure relief device. So I could do the heating on the outside of the box and have the pressure release into the box. And you can see the black hose is from the sniffer, the ProTech cloud chamber sniffer, and the other hose that is coming out from there is from the CO detector. So here is the box in action. You can see there are 2 different smoke alarms on top. That's an optical smoke detector, and it's the CO detector set to 10 ppm and 0 pre-warning. You can see the battery cell in the middle of the 5 holes. On top we have 3 different measurements. We have the sniffer, we have the carbon monoxide level, and we have the temperature. And now you can see that we have some smoke coming from the battery cell, or off gases, failure gases, vent gases. It has many names. If you look at the sniffer setting, you can see that it's set on sensitivity 6. And there are 10 different levels of sensitivity to use. So we're somewhere in the middle. And immediately here it starts to show that there is something going on in this box that the sniffer is sensing. If we look at the carbon monoxide setting, or the meter at the same time, we can see that it's still 0. So the fire sniffer is really fast compared to the carbon monoxide and the optical smoke detector. Now I removed the sniffer hose, and you can see that there are electrolyte bubbling from the top of the battery cell, and we're getting a little bit of hazy atmosphere, and there we had the carbon monoxide. Both the meter, you can see we're at around 11 ppm, and also you can hear that the carbon monoxide detector was set off here. and we fast forward a little bit more. As you can see, we have a lot of pre-warning before the thermal runaway here. The carbon monoxide comes up to around 100 ppm here, and we will soon have the thermal runaway. There we have it. It shot the battery cell out below the box, so that's why we don't see more of it. And here afterwards we can hear the smoke detector go off, but that's due to the fire from the wood in the box, I believe. So we had a pretty decent early warning with both the carbon monoxide and the cloud chamber. The 4 tests I did in this series were basically the same, so I'm just showing you one of them. And here are 2 of the readings from the fibrometer. You could afterwards read the amount of carbon monoxide, and it shows that we had a 10-minute early warning before the thermal runaway. Then I made a side test. I wanted to get some better video of the off-gassing from the battery cell. And here I have a 10 ppm Fibaro smoke detector, carbon monoxide detector, and an optical smoke detector. And if you see here, we have some off-gases from the battery cell. You can hear the carbon monoxide detector going off. And we will look at this. I will fast forward it soon. We have the seconds on top, and then now it starts to count minutes as well. 5 minutes, 6 minutes and counting. And you will see that we will get a very, very dense atmosphere of the white aerosols, but still it didn't set off the optical smoke detector. And that was a bit surprising to me, but for what I understand, it depends on that the optical smoke detector needs a number of particles to be in the way for the light beam where it detects how hazy it is. And the aerosols are so big so that there are not that many aerosols that even make it look hazy. So we don't get that amount of particles in the way of the light beam. So here we see, now we will soon be hearing the smoke detector. So that was quite an interesting test, I think. So day 4 and 5, I got a hold of the lithium ion tamer sensor. And that was really interesting, I think, because this one is detecting the electrolyte, the volatile organic compounds. And it looks like this. It's a sensor that you connect like with a regular network cable, but what you do on the other end is that you only use 3 of the cables to connect to the sensor. 2 of them are plus and minus for the voltage, the power supply, and the other one is the sensor sending out a signal in voltage. So if you have 0.5 volts that is working regularly, and if you have the sensor go to 3 volts, then it is in alarm mode. The white thing you see here that I have connected with the sensor is a Fibaro product again. It's a smart home product that can sense the voltage levels. So I connected the output from the sensor to the Fibaro input. And if it senses that it's around 0.5 volts, it knows that it's in regular working mode. And if it raises to 3 volts, then the sensor knows that it's alarm mode. And in that way I can program it with my smart home to control the smart plugs and shut off the power to the charger and also sound the fire alarm. And here is one of the setups, and you can see here that I have the sensor connected to the black box, and on the phone I have the readings from the lithium-ion tamer sensor. But it seemed like there was a delay there. So on the coming tests, I decided to read the voltage directly instead. In that way, I could see how sensitive the sensor was, not depending on this in-between device. And here is one of the tests. I made 3 of those, and I had the lithium-ion tamer. I had the carbon monoxide alarm set to 10 ppm, and also a possibility to read out the carbon monoxide level. And you can see the voltage level here, measured directly on the output from the sensor. So 0.5 volt is the reading when it's in normal operation, sensing for VOC, sensing for the battery electrolyte. And if you look at the battery cell right now, at the tip of it, you will be able to see some slight smoke coming from it, the aerosols. And now, after only 7 seconds, we have the lithium-ion tamer sensor go to 301 volts, which is the alarm level. So it was extremely fast to detect these levels, and I could repeat those 3 times, same early detection every time. I removed the lion tamer sensor and put a piece of tape over the hole to keep the levels of gases inside the box pretty okay, not letting too much out. But if you look at the box, it's not the best one I built. The other had a tendency to burn, so I made different boxes every time. And you can see that there is a small hole in the bottom between the wood floor and the box. So I guess there is a lot of gases coming out that way. It was also a little bit windy, so I had some wind pressure on the box affecting the gas content in the box. And I guess that is why during all of those 3 tests I didn't have the CO level reach 10 ppm. Since 10 ppm is a very low level, but it's still sensitive for the volume. I need a small volume, and I need it unaffected, I guess, to be able to detect the levels of carbon monoxide that I want to detect. I will do a bit fast forward here, and you can see that we got quite a bit of haze within the box, still not enough carbon monoxide to start the alarm, and then the haze ventilates through the openings, and I never got a CO reading or CO detection in this setup here. And that makes the lion tamer sensor even more impressive, that even with this kind of ventilation it got such an early warning with that sensor. So I'm pretty sure this will work with my e-bike battery, and I will be able to connect it to my smart home and have a smart plug that shuts off the charging if it detects smoke or off-gassing from a battery cell, and it will start the fire alarm. So I built this charging and storage box for my e-bike battery, and as you see, there is a lion tamer sensor on top. There is the box with the Fibaro smart implant, and I will put the battery in from the opening where I have the fire blanket, As I said, it's just a prototype, so I will have to work a little bit more on the fire blanket part, I think. But what it will make me do is that I can have the battery in the box. If the fire alarm goes off, I can carry the box in the handle outside without needing to go through any emergency stairways or anything, just put it in the garden. You can also see that it's made of wood, which wouldn't be the best option, I suppose. But in my case, I'm always charging at home. The wood will give me enough protection and enough insulation. So if I would get a thermal runaway when carrying the box out the few yards to the garden, it will protect me, and then it will probably break or burn when it's in the garden, but that's not my main concern. It is to get it outside, and then there can be a thermal event in the garden. So will it work all the time? I don't know. There could be a thermal runaway really fast without any pre-warning, and in that case it will not work. This diagram here shows different parts of the pre-steps to a thermal runaway, and as you can see there are several bubbles before the thermal runaway with different steps, and maybe some of them, if I stop the charging, it will stop the process of going to a thermal runaway. But at some point it will probably be a self-sustaining process so it will go to a thermal runaway anyway. And the same report where I got the numbers from the beginning, it's from 2015, so it's really old knowledge. What they say is that if you measure voltage on the battery cells, you can get a 2-minute early warning. If you measure the temperature on the cells, you can get a 7-minute early warning. But if you measure off-gassing, which is what I have done in my tests, you can get between 7 minutes to several days of early warning. And that's what I really like about this way of detecting the battery fires. So to summarize the results again, the thermal runaway started from around 14 minutes after I saw the first smoke coming from the battery cell. The carbon monoxide, the domestic fire alarm, did not work at all. It always was after the thermal runaway. The optical smoke detector worked once, and all the other time it didn't work until after the thermal runaway. The carbon monoxide alarm set 10 ppm and no pre-warning give us about 10 minutes of early warning. And it turned out it was a little bit sensitive to the volume. It needed to be a closed volume so it could sense the carbon monoxide. The cloud chamber that was set to sensitivity 6 was around 30 seconds. And I guess if I would have increased the sensitivity a little bit more, it could probably be around the same level that the Lion tamer sensor was, at around 7 seconds. So with that, I would like to thank you for listening to this, and have a good day. Bye-bye.